Welcome back everyone to the Hello World guys. This is another episode of the Raycaster game in C++ series, and in this video we are going to continue our editor by implementing the editor class and implementing some functionality for moving with drag and also like scrolling in and out, so that's going to be pretty awesome. So without further ado, let's jump right into the video. So I have gone ahead and opened up my project directory here, and inside of this I have created two new files. So if I get a listing of this, you can see that we have got two new files. One is editor.h and the other is editor.cpp. Now these files represent our main editor. First of all, I'm going to go under vim and open up main.cpp and also editor.h and editor.cpp. Let's open those as well. But first of all, we are going to go under main.cpp and get an overview of what we have got here. So the idea is that we have got a class called editor, which is going to handle all of our main editor functionality. So we have got that class, of course, in editor.h. You can see I include the header here. Now in these lines, and you can see that we create a new editor and then we call initialize on the editor. Now let's just go under editor.h to take a quick look at our editor class. You can see that we have got a bunch of includes here, and the actual class consists of basically three functions. One is the initialize function, which takes in a render window called window, and the other is the run function, which also takes a render window called window. Now the thing to note here is that this is not taking a render target, it is actually taking a window, because we need to do some other stuff as well, not just render to the window. So for the editor, we'll need to get a render window, we can't just take a render target. And the next thing we have got is that we've got a function here called handle event, and we'll understand the purpose of this in a second. For now, let's just keep these two functions in mind. And now I'm going to go back under main.cpp. So we call editor.initialize with our window, and after we have initialized that, you can see that we are going to get to this handle event in a second. First of all, let's go down here. So you can see that if the state is in the game, then you can see I've got a new function here which calls window.setView window, and we just do execute this. But we are going to why we are doing this here, we are going to understand that in a second as well. First of all, let's go to our else here, where we are actually doing the editor code. So in the last video we were drawing our map. We also call editor.run, as you might have expected. So we just call editor.run and pass it our window, and that should that should be it. So now let's go under editor.cpp and see what we are doing here. Now currently, of course, there is no actual editing functionality implemented, but we can move around the map and zoom and stuff. So we are going to take a look at that. And now in the private variables, you can see that if in the class editor we have got three private variables. One is a boolean called isFirstMouse. Now the reason we use this is because we are doing mouse capturing. So the idea is that when the user right clicks, we just capture their mouse. So let me actually show you. So if I go here, you can see that we have got this. I can press escape, and then if I just do anything, currently nothing happens. But if I right click, my mouse cursor disappears, and now I'm able to move around the map. I can move it left or right, and I can move it up or down, and I can just freely move the map with my mouse. And also I can actually scroll the map if I want to. I can scroll out, I can zoom in if I want to get a deeper look at things, and I'm going to just get it back to normal view, and you can see that we can move the mouse around. So for this, we are basically what we are doing with this is that we are capturing our mouse. Now the way that's done is that if I go under editor.cpp, so that's basically the whole content of our run function right now. So you can see that we first of all check if the right mouse button is pressed. If the right mouse button is not pressed, we just set isFirstMouse to true, because the next time the right mouse button is pressed, then that's going to be the first time the right mouse button is pressed. And then we are going to set window.set, we just set the mouse cursor to be visible. And now when we actually press the right mouse button, we check if when we press this, it is our first mouse. So which means that the user is just capturing the mouse. If that's the case, then we take our last mouse. We basically take this variable that we have got, which is a vector2 of integers called last mouse position, and we set that to SFMouse get position. And the reason we pass in this window argument is to get a mouse position relative to the current window and not relative to the actual whole screen. So we get our last mouse position like that. We just use SFMouse get position. And once we have got that position, we the way we'll use this is that this will be used to calculate the delta, so how much the player actually the user basically moves his mouse in like one frame. So we store that last mouse position here, and this is going to stay the same until the user actually releases the mouse. You can see that we also set the is first mouse to false here, and in if this was not the first mouse, it was second or third or whatever, so like the frame that when the user actually pressed the key has passed, and now we are getting onto the frames when the user is holding down the mouse button. Then we first of all get the new mouse position with SF mouse get position, just like we were doing earlier, and then we calculate a mouse delta. For that we just take our mouse position and subtract the last mouse position from this. Now we take our view, and we'll get to the view part in a second, and in the end we just set our mouse's position. We just manually set it to the last position, and of course we pass in the window. The way this will work is that it will make sure that our mouse stays at the same position, and we just use the delta to move our move our view. So now that brings us to this actual third variable here that we have got called view. Now in SFML we have got windows which have got size and everything, but in order to modify that window, and if even if the physical size of our window is different, we should be able to zoom in and out and move it around without having to implement it manually in our like actual editing function, our drawing functionality. We don't want to implement that manually, so we can use an SF view for that. So we have got a variable here that stores the editor view so that it persists between sessions, and the way we'll use this is that we just in the initialize function, you can see that we set our view to whatever the Windows view is. So when we call this, we just set it to the Windows view, which means the default size and the default positioning and everything. And then whenever the user moves his mouse, then we get the view center, and we subtract the mouse delta from that, and of course we need to cast this to a vector 2f, and then we set the view center back to that. And that in the end, of course, actually this is not necessary, we are doing that in the end. So after in the end of the loop, we just call window.setView and set our view variable that we have got, and we set the Windows view to be that. So this way we are basically resetting the view every frame. And because we are resetting the view in the main.cpp function, we need to in the where we are doing the game state, we need to make sure we set the view to the default view of the window. So we can do that by getting the default view. And the reason this is important is because our Raycaster needs to kind of work with the default view. It's not meant to work with any other view. So if in order to prevent any problems, we do it this way. Now in editor.cpp, back inside of here, you can see that we set our view here, and if and that's pretty much it. Of course we also set the Windows cursor to be not visible when we are actually grabbing this. So that's all for the mouse, and that works for moving our window. And the next thing we'll look at is the actual scrolling. Now the problem is that we can't actually access a global scrolling state, because scrolling is always just based on delta, so we need to read the event for that. And since this run function is just getting the window, we can't read the event. The events have been processed before. We have got another function called handle event, which will take a const reference to an event and basically do whatever we want with it. So inside of this, you can see that we check if our state is editor, and if that's the case, we just tell our editor to handle that event that we just got. And of course if the state is game, then this won't do anything. We'll just process the default events and not do anything else. So now inside of editor.cpp, in handle event, you can see that we take an SF event called event, and we check if the type was mouse wheel scroll. Currently this is the only event that we need to care about. And if it was the mouse wheel scroll event, which means our mouse's wheel was scrolled either up or down or whatever, so if that's the case, then we could create this variable called zoom. Now this zoom variable, the reason we need to have a zoom variable is because that way we'll be able to just use the zoom function of the view. We won't need to scale the actual size of the view manually. You can just use this function. Now this function takes in a relative view, so it takes it relative to the window's current size, not to the default size or anything, the view's current size. So we need to make sure this zoom is also relative. So for that, this scroll wheel delta that we have got, if our mouse wheel has scrolled down, then it would be negative, and if our mouse wheel has scrolled up, then it would be positive. And it is not guaranteed to be exactly 1 or -1 or anything else. It can be any value. So the way we calculate that is to reduce the sensitivity of our scrolling. We first of all multiply this by 0.1. As you can see, I'm multiplying this by 0.1 here, and then we subtract that value from 1. So for example, if we move forward and it register an event of 1. So it will the delta was 1 for scrolling upwards, let's assume, in a situation. Then we multiply that by 0.1, which gives us 0.1, and then we subtract that from 1, which gives us 0.9, and in the end we end up shrinking our view size by 10%. So yeah, that's basically how it works. And if it's negative, then we'll automatically have a value greater than 1, and as a result we'll increase the view size. So yeah, this is actually going to work quite well. So as you can see, if I just run make, you can see that we can switch into editor mode, and I can like move around, and I can zoom out, and I can move around here as well. I can zoom in, and I can still move around. And if I go ahead and go under back to my game view, you can see that the view of the game is not affected. And if I go back under editor view, our view is still where we left it, so it persists between different sessions. That's why we created a class member for that. So yeah guys, this is pretty much it for this video. I'll see you in the next one, in which we'll start with some of our actual editor drawing functionality and stuff. So stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one. And